Example, evaluate the integral of sine of 2t plus 1 divided by cosine squared of 2t plus 1 dt. This integration will involve two substitutions. We see 2t plus 1 as an inside function of a composite function. So our first substitution, we will let u equal the inside 2t plus 1. Proceeding to take the derivative of u, we have du, and the derivative of 2t plus 1 will have 2t dt. Our original integral has dt. Our substitution so far has 2 dt. In order to be able to do a direct substitution, divide by 2 on both sides so that 1/2 du equals dt. Let's make substitutions. Where 2t plus 1 was, we put in u. Where dt was, we put in 1/2 du. The substitution results in the sine of u divided by cosine squared u times 1/2 du. Using properties of integrals, we will move the 1/2 constant to the left of the integral. Thus, 1/2 the integral of sine u divided by cosine squared u du. We are ready to do the next substitution, or the 1/2 the integral of sine u divided by cosine squared u du. Using properties of multiplication, the commutative property, we will write this again as 1/2 the integral of 1 divided by cosine squared u times sine u du. This visually makes doing the next substitution a little bit more straightforward. Let's let v equal cosine u. The derivative of v is dv. The derivative of cosine u is minus sine u du. Our integral has a positive sine u du. In order to make a direct substitution, we need our negative sine u du to be positive. So let's multiply by negative on both sides. Negative dv equals positive sine u du. We'll make our second substitution. Every term that's expressed in terms of u, we'll replace it in terms of v. This will result in 1/2 the integral of 1 divided by, where cosine u was, we just put in v. That's v squared. And sine u du in terms of the variable v is negative dv. So we replace the sine u du with negative dv. Proceeding, we'll move the negative that's multiplied to the dv to the outside of the integral symbol. That becomes negative 1/2 the integral of v, and we'll write it to the power of negative 2 dv. Using the power rule for integration, we will integrate v to the minus 2. That'll give us the negative 1/2 constant stays put. Remember, the power rule for integration, you add 1. We had v to the minus 2. Add 1 to the negative 2, that'll give you negative 1. V to the negative 1, then 1 divided by 1 plus negative 2, that's negative 1. So our integral is negative 1/2 times negative 1 times v to the power of negative 1 plus c. We rewrite this getting rid of the double negative. That'll be positive 1/2 v to the minus 1 plus c. Continuing, we need to replace or substitute back the variables. Remember, v was our cosine u. So 1/2 v to the minus 1 plus c will be 1/2 cosine to the negative 1 of u plus c. Let's rewrite the cosine to the negative 1 with no negative exponent. That'll be 1/2 times 1 over cosine u plus c. Using the trig identity of what 1 over cosine u is equal to, we write 1/2 secant u plus c. Let's replace the u back with our original substitution of 2t plus 1. This will be 1/2 secant of 2t plus 1 plus c.